we're going to go into a live demo of making the MFE ecosystem. This is quite a challenging bit of code to write, and there's quite a lot of code. So I do have a handy cheat sheet here in case I need to refer to anything. And if I ever do start looking like that, don't worry, it's all written down. What you can see here is the actual Miro board that provided the diagram in Ben's explanation. We're going to jump into that in a second, but for beginning, I will just introduce myself. I'm Pip. I've been working at Tesco for 4 and a bit years now. You may know some of the code I've written. If you've ever used any of the self-service machines in the UK, then that new UI that has been powered by the retail platform, it's come from these hands, for better or for worse. So Ben and everyone else has talked a lot about micro-frontends today. Hopefully you're starting to see the benefits that they can provide you. Isolated development and deployment, autonomy to teams, single domain concerns. Now you will hopefully see it in person. So the key we've got up here says that the things we need to make are the things in blue. The things we don't need to make for this demo are in red. So thankfully, we don't have to wait 9 months for a new user to pop out. We're just going to assume that I'm the user. What we do have, though, already provided to us is a browser and some asparagus packages. That's the internal framework that we've been talking about. What we're going to have to write is the stuff in blue. So we're going to have some assets that we need to provide to the orchestrator. We're going to have to write the browser bundle for the orchestrator to go fetch and load the modules. So why don't we jump right into it? So the first thing, on an initial server render, which is this pink line, we see that the orchestrator server is going to need to go fetch some information from the orchestrator assets. Ben told us already that it needs routes, layouts, a template. It also needs to know the micro-frontends that it actually speaks to and where they live. So let's jump into the code. And spoiler alert, I've already written this. It's super nice and simple. I'm just using a JSON server. That's all. I feed in an asset JSON file. And what this does is it turns all of the keys into endpoints that we can call just straight away. Easy peasy. So here you can see the MFE servers. We've got them named MFE 1, 2, and 3, all hosted on localhost 4,500 plus. We've got the layouts that we're going to support for this ecosystem. So we have a home page. We have a test route. I should have probably named it a bit better now thinking. Naming, the main problem of engineering. And we've also got layouts. So we're only using one layout in this case, but you can see how we can reuse the same layout in 2 different routes, but feed in 2 different MFEs as a placeholder element. So if you have a consistent design, you don't need to reinvent the layout every single time. You just feed in a new MFE. Quite simple. And the final thing that we need is a template. So this template is where we splice and inject all of our HTML, all of our style, all of our lost screen. Let's try unplugging and plugging it back in to see if that fixes it. Magic. Live demo. So this is where we're going to inject our head content. This could be any styles, CSS, anything you want. And then the body as well. That will be your actual content that you're going to view. Right. So I made it earlier. That's a few more. There we go. Right. So here you've got the assets directory, first one. We're just going to start this up. Nice and simple. And it even tells us, using JSON serve, the URLs we can hit. So right there, you can see that the MFE servers returns the array for the key we've provided. Easy peasy. We're all following along, yeah? That's part 1. It's pretty simple. We've already ticked one part off, right? They're all going to be that simple, yeah? And unfortunately not. Now we have to actually start writing the orchestrator. So we're doing the server render first. The orchestrator needs to make requests from the server to the assets. So let's start off. We've already seen the assets, and I've already got a template for the orchestrator loaded in. This is a very basic Express application with some basic serving of static assets and built browser assets. Okay, so let's write a fetcher and good old browser spec. So we need to import it because it's not just on our global, isomorphic unfetch. So we have a fetcher, easy. Thankfully, we didn't have to write that. What we are going to need are some types. So we're writing this in TypeScript as well. That's a bit of added complexity. Bear with me if it goes wrong. We're going to bring in the micro-frontend servers from our Asparagus package. And don't get too excited. This Asparagus package is hosted on our Nexus, so you can't quite install it yet. But maybe one day, if we get enough demand, we will look to open source it. So Asparagus server provides the micro-frontend server interface. And also, we're going to import the layouts and the routes. And they come from the Asparagus core. Right, now let's quickly write some fetches. They're all going to be on localhost 4499. That's where our asset server is running. So let's call this an asset host. And then we're just going to write the fetches. So fetch micro-frontend servers. So this needs to be a function that returns a promise of micro-frontend servers. Smart check-in didn't bring that up, but there we go. Right. So now we just call isomorphic onFetch, use a template literal for the asset host, and MFE servers. Now, fetch returns a response. It doesn't return the JSON. Easy peasy. Just chain it then. Say, on the response, we're going to return another promise, res.json. Easy peasy. One fetcher done. And in fact, the others are very similar. 2, 3, 4. So we're going to have fetch layouts, which returns a type layouts. And we're going to remember not to keep that as MFE servers. It's going to be the key that we've specified in the asset service, the layouts. Let's also bring in the routes. And let's try and sit down so I can see the screen as I type. And finally, what was the last bit? There's routes, layouts, there's micro-frontend servers, there's the template that we splice everything into. So routes, template.html. The only difference for the template.html is that it's not a JSON response, so we're just going to read the text body. And that returns a type string. There, fetches already done, no problem. Now we have the fetches, we need to use the Asparagus server package to actually create a request handler. So for any request that comes into the orchestrator server, we need to know where to go to fetch the data that Asparagus is doing. So the orchestrator server tells the Asparagus package what layouts, template, and routes and servers to use. So we're going to create a request handler. So let's call this the Asparagus request handler. And that uses the create SSR package method exposed by the server package. So create SSR. Now, it takes a config object, which is all of the fetches that we've already passed in. The idea is that with orchestrated assets, they could change in the background, and you wouldn't want to redeploy your orchestrator to serve those changes. That's why we pass in functions that return the promises of those values instead of just passing in hard-coded values. So let's say that the micro-frontends are returned by the fetch micro-frontend servers. Seems pretty sensible, right? Layouts can do the exact same. Fetch layouts, routes, fetch routes, and finally template. Fetch template. Okay, not quite done. We need to provide a couple error handling scenarios. So this could be, if your main MFE fails, maybe you want to serve a 404 page. Or if, say, for example, your footer fails, you want to serve the entire page still, because people don't use footers in 2021. So we are going to provide some on-error handlers. So there's the on-MFE error, which takes an event. And we're just going to, for our example, just log out that event. And then there's another handler that looks basically the exact same. What happens if you're trying to access an authenticated route, but the user's not logged in yet? Maybe they're trying to do something bad with the system. Maybe their cookies just expired. Regardless, we need to handle that. So we have a on-auth error. And the very final thing, we just want to give this a name. So shall we say MFE Budapest? Let's have a look. So we've called this the SPA package, and we're going to call this MFE Budapest. Lovely. Done, right? No, we're not using it yet. So an express middleware, and we're going to use it for all incoming requests and actually use that request handler that the server-side request handler returns. So we're actually pretty close to being done for our server renders. The only other thing we need to do is have content to render. So let's have a look into MFE1. MFE1 is going to do a bit of server rendering, and it's already got this server set up. Actually, it doesn't need to do much more. So the shared directory here is what most would call the entire application. It exposes a MFE1 method that we want to use in the MFE server to server render. So what we're going to do, we're going to import MFE1 from shared, and now for any request, we're going to say, we don't care about what we do with the request, we just care about the response. All we need to do here is return this content, so res.json, and whatever the body is, we're going to render the content. But that's not quite how we do server rendering, is it? So what do we also need? Let's bring in the render to string method from React DOM. Oh, not import. And now we can say that the body is actually the return of the render to string method, MFE1. And now that is actually it. That's all we need to do for server-side rendering. If you don't have any bundles that you need loading, if you don't have a browser package that you need, that's all you're going to need for an MFE. If your application is super simple, you just server render. Let's have a look if that builds. So let's build MFE1, clear that example, and build the orchestrator. We're going to start up MFE1, start up the orchestrator, and a big fingers crossed, when we hit localhost 4500, hello world. There we go. Demo done, right? Surely. Yeah, I'll take a clap for that. So there's two really interesting things here. I've already told you what the homepage route looks like. I've told you there's an MFE2 that exists, but MFE2 isn't loading. Well, we've not provided any on MFE error handler, so it implicitly just protects the page load and renders what it can. If it's not seen MFE2 respond to any requests, and we're not even running an MFE2 server, it will still render the page. And now the other second bit, I wonder if anyone's already noticed it. Look at this code that we're rendering. You're doing a server render, and you're picking the time to render into the content here. Well, that's just going to be the server render time. And it's not updating. This is why we need to load the modules. This is the orchestrator's browser fetching. The orchestrator browser needs to fetch and load the modules for each individual MFE that we're doing. So, actually, it's not too bad. We've already ticked off 1, 2, 3 free boxes, or parts of free boxes. Let's jump over to the orchestrator browser. This is where it gets a bit more difficult. So the orchestrator browser uses Asparagus and the Asparagus browser package, but the actual module resolution strategy that you use, it doesn't care. You can pass in whatever module resolution strategy you want. So we have decided internally to use module federation from Webpack, which seems to be the industry pulling us in that direction with the support and the teams that are picking it up. Here I'm going to show you how we use module federation in order to actually load these MFE bundles. So let's first start by making sure that all of the MFEs that we have expose an interface that Asparagus can actually consume. We call that the micro-frontend module interface. Let's import that straight away. And we're in the MFE1 source browser code here. So we're going to import micro-frontend, it's a long word, module from Asparagus browser. Right. So we need to have a module that is of this interface. So let's call that module, which is of the micro-frontend module interface. We'll leave it empty for now, but at least we have a module that looks like it. And in fact, let's think. Right, so what does this expose? We've heard a bit about this before. It exposes an initialize method, a mount, an update, and an unmount. This should look really familiar if you've ever used single SPA, or even it harkens back to React lifecycle methods. They're very, very familiar. Let's just write those methods. Right, so what do we need first? Initialize. Now, initialize, you can basically pass in an interface from your orchestrator or Asparagus, and you could initialize your application in some way. Maybe you want to pass in a particular logger. Maybe you want to pass in a particular APM tool, or initialize any of those and pass them in. This is how you could do that. For this example, we don't need it. So we're just going to give it a no-op. Okay, so now the mount. This is the more interesting part. When we render MFEs onto a page via browser rendering, we need to be told what element we're targeting to render. So just like you would do a React render when you're targeting the root, and I'm sure there are many people that have applications that still have an ID on the page called root, where they've just loaded it in from React, we need to target an element just like they do. So we get passed an element by Asparagus. But sometimes you may have elements or you may have MFEs that don't actually care about rendering any content. So that's made our type a bit more difficult. We now have to say if there's no element, don't do anything. You could have analytics MFEs that don't want to render any content, but they want to listen to events in the MFE ecosystem. That's what this optional element is for, basically. But if we do have an element, great. What if they've done server-side rendering? Okay, next part. How do we do that? We check to see if there are children nodes on the element already. So if the element has child nodes, then we know that the application has been server rendered. Now we need to hydrate. Where do we get hydration from? That's the React DOM. So we're going to import that. And we're going to say React DOM hydrate. Now we actually need an application. We've got to this point and we've realized, oh no, we don't actually have an app. So let's quickly write one. This app is just going to be called app, and it takes props. We don't know what those props look like at the moment, but if you wanted to, you could have a fully typed system. Asparagus already does some error handling for us, but what if we wanted our error handling to actually be done by this MFE itself? Okay, well, why don't we have a error boundary from React error boundary and a fallback component that's just the most simple errored component you can have. Now we're going to wrap, well, we've already seen the shed file, so let's just say, let's bring MFE1 in. From shared. And let's try and render that with the props they're getting passed in. Now we have an app, we can hydrate the server rendered content, we don't care about the props at this point, against the element that Asparagus has told us to render against. Easy peasy. What if it's not server rendered? Well, that's also pretty easy. We're going to say React DOM, and we're just going to call the render method with the element that we've been passed. So in the exact same way, there's an app, there. Right. Let's have a look where we're getting complaints from. Void is not assignable to type. Interesting. So we have an app. Simple mistake. Curly brace is actually supposed to be brackets. There. Autocomplete. You can't live with it, you can't live without it. No complaints anymore. That's our mount method. Done. What if you've got an update? What if there are page navigations? Well, that's the update method, unsurprisingly. So update looks very, very familiar. In fact, we can copy and paste most of this. That's update. If there are, update may be called by Asparagus for a couple different reasons, and just like in React, you shouldn't be betting on when updates will happen. You just need to try and memorize inside of your own app to perform as best as you can. Finally, unmount. So you've got one page, you've navigated to the next page, but the content that was on the page doesn't exist anymore. Okay, so let's say if there's an element, unmount would be helpful. If there's an element, if there's no element, we're not going to do anything. If there is an element, we're going to unmount the component at that node and free it. That's literally it. There's your MFE1. That's the browser implementation for the module. Right. Still not quite working, is it? Orchestrator isn't fetching this quite yet. So this is being built and exposed by MFE1, but nothing's actually going to get it. Let's write the Orchestrator browser. This is quite a long bit of code, so bear with me. So the Orchestrator browser basically contains a module registry and does the loading for these modules. So what we first need is to say, okay, what does our module registry look like? So let's call that a module registry, and we'll call it a record. And this is going to be either a fetching module, so it's asynchronous, and it's not resolved yet, or it's going to be the actual resolved value. So let's say if it's resolved, it's going to be a promise. Oh. If it's not resolved yet, then we'll expose a promise to the module. So that's a promise of a, what is it? It's a micro-frontend module interface, so micro. And where does that come from? That comes from the browser as well. So let's import that. From the Asparagus browser. And actually, let's close the generic. Right. What if it has resolved? Let's add that as well. So if it's resolved, well, then we're just going to expose a module, which is of type micro-frontend module. That's the type of our registry record. Now we need to use that type in a map where we can say that MFE1 relates to this record. So let's call this the module registry. And this is just going to be a new map of type string, which is the name that we're passing and calling for, and the module registry record. And we just instantialize it as an empty map. Okay. Now, let's do some mapping as well. So we know we have some MFEs we need to load. What does that look like? So we're going to call that the import map. Now, the typing will get a bit interesting here because the MFEs in this example aren't exposing types. So I'll just use some TS ignores, but the rest of it should be fine. So we have a record with the name of the MFE and a function that goes to fetch a module. So what does that module look like? We've got an example here. It's a default export which has the micro-frontend module as an interface. So let's say that there's a promise, not quite in those capital orders. There's a promise which has a default export which has a micro-frontend module. And now this we can give names to. So there's going to be an MFE1. Now if you've seen this import style, this is the basis of module federation. This is ECMAScript 2020 or 2021, but basically this import is going to return a promise which resolves to the imported module. So we're going to say MFE, MFE1. This is a bit of Webpack magic. And here you can see the types that aren't being exposed by this package, and there's not a dependency. So for now, we'll just say, and don't tell my boss that I just used tsignore. This Webpack magic, it's doing a lot under the hood. I'll show you the Webpack config in a bit, but just know that each one of these just references an MFE that we need to load. And unsurprisingly, MFE2 and MFE3 exists as well. Right, that's our import map. So we have our registry, we have an import map. What are we missing? Well, actually we haven't gone and fetched any of the modules yet. We're not calling this. So let's write our module resolution strategy. So this is going to be called the resolve, very long name, micro-frontend module. Now this function is going to take a name. That's this name right here. What module are you trying to load? Asparagus tells that to us. So we will take a string and we will return a promise which loads the micro-frontend module. What am I missing here? Oh, I haven't written it yet. Good old TypeScript. Right. So first what we want to do is we want to check if we've actually loaded the module before. So let's have a look. We'll say module record, maybe. And we're just going to check to see if in the module registry there's already an entry with the name. Well, on the first run, there definitely won't be, so let's go and fetch it. If there's no module record, I'm just looking to see why the colorings look a bit off. Promise micro-frontend. Ah, here we go. I did not finish that. Lovely, styled. Right, if there's no module record, we need to go fetch it. But we know it's not resolved yet, so we know it's going to be a promise. So the module promise is just the import map, look up the name for it that we're passed, call the function which returns the promise, and then when it's resolved, you're going to have a module, exports, and module exports we've already seen up at the top. That has a default property, so we're going to say the module is the module exports.default. Okay, so now we've fetched it. We actually need to add it to the registry, right? So we're fetching it. We haven't got it yet. Let's say the module registry set with the name that we've been passed. It's not resolved yet, and the promise is going to be this module. Sorry, this is after it's been resolved. That's my mistake. So it's been resolved. We've got the module, call it module, and then we need to return the module. So this is after the request has actually been fulfilled, the promise has resolved. We need to say, while that is in flight, that this request is in flight, basically. So let's have a look. I think we're missing another curly brace, perhaps. We're going to say module registry and set the name. Now this is when it isn't resolved. And the promise is module promise. Right. That's actually not too bad. That's the initial load of a module. Well, what if someone requests a module when the request is already in flight? What if the promise hasn't resolved yet? So let's handle that. So we're going to say else if the module record is not resolved, but at least it exists, we're just going to return the module record promise. So now we've stopped it from going to make another fetch. It's already fetching the data once, don't fetch it again. Okay, and the final case, well, what if it's already loaded? What if the request isn't in flight? What if it's already resolved? Let's return that. Let's return the, again, we have to meet this interface of the promise, so we're going to say promise.resolve of the module record dot module. Right, how are we doing? Well, I think we're missing something over here, aren't we? We actually need to return the promise. And then hopefully, TypeScript won't complain at me. That's pretty good. I think that's working. So we have the module resolution strategy. We've got the caching, we've got the registry of records. Now, let's actually use it. So let's import from the Asparagus browser the create SPA method. And all we need to do to finish off this Orchestrator's browser implementation is to, as a default export, do that. We just need to call create SPA with our module resolution strategy, whether that's module federation or any other module resolution strategy that you want. And this will load the modules. So, fingers crossed. I'm going to give this a little restart and build. And hopefully, we're about to see a ticking clock. There we go. That's a server render being hydrated on the browser and loading the bundles. And in fact, over on this right-hand side, you'll see for each MFE that we're able to load and all of the federated and shared packages managed by Webpack, nothing that you need to control, nothing that you need to worry about or maintain yourself, it's all done for you. With a combination of your module resolution strategy and Asparagus, you can literally start up an MFE in, well, I make that, what, 25 minutes, if that? It's that simple. Right. Hang on, we're still missing some stuff, aren't we? Well, we have MFE1, we have MFE2. We don't have MFE2 yet. Right, let's have a look. So what I could do, I could just copy and paste this, couldn't I? It'd save us a bit of time. Or we could be even lazier, and in the browser package for MFE2, we could just import an adapter layer. So whatever adapter layer you need, whether that's Vue, Angular, React, you can just create an adapter layer that transforms all of the hydration, all of the rendering for your particular Vue library into an adapter that supports the micro-frontend module interface. So let's have a create React. Let me double check this interface. Create React MFE from Asparagus React MFE. Let's bring in MFE2 as well. That's also in shared. And let's just call that. So we're going to pass a root component. This is whatever you're wanting to render. And then we're also going to give it a name, just so you can have some nice logging messages. Right. I've already set up the server for MFE2, so shall we just give it a go? Let's build it. And fingers crossed, Webpack's happy. Start the server. Give it a refresh. There we go. And actually, you'll see that this is the logging we provide by default. But some new federated packages are being loaded. 4502 is the host for MFE2. And so you can see that we're going out to fetch those resources as well. Now, I can click to go to test, and without any new loads, apart from trying to get MFE free, we're doing SPA in the browser from server-rendered content on different applications. So hopefully you can see that you have complete autonomy to make any changes you want in one package. Say I'm in MFE2, and I say click to go to test, or I'm less helpful for accessible users, and I just say click here, which is terrible. But if I restart, still saying click to go to test, that's because we're part of the same session. We've already loaded the module. So if the server goes down, we still have full support. For as long as they're in that journey, as long as new server requests don't come into MFE2, I can restart, and I haven't touched the orchestrator, I haven't touched the assets, I haven't touched MFE1, MFE3, you have new code deployed. Right, let's look at MFE3 as well. MFE3 is already set up, but I want to show you another benefit. Now, when you're developing, you don't need to have an orchestrator running, because I don't want to have to run the header, the footer, all the other pages in the application just to make my change to the cookie policy, right? So what does that look like? I've got a Webpack config here, and I'll touch on this very briefly now, but this is the Module Federation plugin package. And we name not only the MFE that we're using, but where we host our federated packages, and any packages that we may wish to share if we're not particularly fussy about versions and we're trying to be more performant and load less packages across the ecosystem. And if you look in the orchestrator, Again, Webpack magic is done here. We've got a list of all of the remotes that we support, MFE 1, 2, and 3 with all of their remote entries. In Tesco's world, it gets a bit more complicated, but I won't go too much into it. You also have to think about how you handle browser caching of modules so that when you release new code, it doesn't get cached if you need to make a hotfix, anything like that. So it does get a bit more complicated, but this is just for this example. Here you can see this is the naming convention Federation uses, but that's just a URL to a resource to go fetch. What I did want to show you in MFE3 is the difference between what we call an orchestrated environment and an isolated environment. The orchestrated environment is expecting that you're running with an orchestrator, you're running all the other MFEs. The isolated experience, well, be prepared to be a bit surprised. This gets a bit weird. But now you have to think about how you're developing your application in isolation. So when we build with an isolated environment, what we can do, well, we can say, go to the application, and that's MFE3 just by itself. So MFE3, to develop and make changes to, doesn't require you to be running all of the other MFEs. This is a main point of contention for us as well, a main point of focus for us to improve the developer experience. Imagine there's an API that's gone down that's brought down another MFE. Well, if you're developing this MFE that doesn't require that data, you don't need to run that. You don't need to be blocked in your environment if all you're doing is making a simple copy change. It's that simple. So I hope that you've seen the benefits and the autonomy it brings you, the improved developer experiences, and what I really need to make clear, not a picture of Japan, is when you've set up the orchestrator, it's pretty much done. One team just has to manage and set it up. Then you, as engineers, go away and have to develop your own MFEs, and you don't have to be impacted by MFE 1, MFE 2 if you're not touching it. You don't have to be impacted in making changes to Orchestrator. The only thing you need to do is when you introduce a new MFE to the environment, add it to your assets. A simple CDN redeployment. That's it. So that's pretty much all I was going to show you. I hope it's made sense. If it hasn't, ask me questions after, but it really can be that simple. Hope you've enjoyed. Cool. Thanks, everyone.